Picture this. You stumble bleary-eyed into the kitchen at 6 a.m. and find your smart toaster wearing sunglasses and reading a dog-eared copy of Plato's Timaeus. It refuses to toast anything until you answer its pop quiz. Friend human, do triangles glimmer in some cosmic vault awaiting discovery like buried treasure, or did your species invent them the way it invented karaoke and pineapple pizza? You reach for the coffee, stunned that an appliance has ambushed you with metaphysics before caffeine. Yet the toaster has hurled you headfirst into one of humanity's oldest intellectual wrestling matches. Is mathematics unearthed or manufactured? To see how we got cornered by a breakfast device, let's time travel past the Pythagoreans, who in the 6th century BCE wandered around southern Italy in matching robes chanting that all is number. They weren't being poetic. They really heard music in integer ratios, tasted geometry in beans, and possibly calculated the optimal angle for beard grooming. Legend says one initiate discovered square root 2, an irrational number that blew lurid neon holes through their neat tapestry of whole number harmony. Depending on which ancient gossip you believe, the poor fellow was thanked with a one-way boat ride off the island. Lesson 1. When math looks discovered, its contrarians sometimes get deleted. Meanwhile, far across the Mediterranean, Egyptian surveyors were remeasuring Nile floodplains each season, iterating a pragmatic geometry good enough to build pyramids that still refused to fall over. They didn't care whether the Pythagoreans claimed numbers lived in some celestial Airbnb. They treated geometry as a tool, a hammer their civilization invented to keep land taxes predictable. If it worked, that was proof enough. Discovery versus invention? The scribes shrugged, sharpened reeds, and tallied crop yields. Jump ahead 2 millennia to Renaissance Italy, where Girolamo Cardano, a physician, gambler, astrologer, needed better odds at dice and better equations for finance. To solve cubic polynomials, he cheerfully birthed imaginary numbers, those mischievous roots of -1 that sound like unicorns but now encrypt your WhatsApp messages. Cardano might have insisted he discovered them, yet entire university faculties rolled their eyes for centuries, calling these quantities false or sophistic. Until Euler, Gauss, and friends unleashed complex numbers on electromagnetism, the physics world shouted, "Mine now," and retroactively declared them inevitable. Moral: sometimes we invent mathematics Monday, ignore it Tuesday, rediscover it Wednesday, and by Friday it's running the power grid. The pattern repeats with calculus. Newton and Leibniz independently conjured a formalism to describe changing quantities, planetary orbits, cannonballs, how fast a cup of tea cools when you blather instead of drinking. Arguments flared over who deserved credit. Entire national academies traded snarky Latin pamphlets. But nobody asked gravity whether it preferred Newton's dots or Leibniz's fancy elongated S. Nature performed the same pirouette either way. Was calculus lurking under the apple tree waiting to be noticed, or did Newton fabricate a language so convincing that the universe obediently conformed? Enter the 19th century all-stars: Gauss, Riemann, Lobachevsky. Euclid's fifth postulate about parallels had survived unmolested for 2,000 years, but curiosity-drunk geometers decided to negate it just to see what happened. Surprise! Brand new, consistent geometries erupted. One day, these heretical spaces would become tastier to Einstein than a plate of Bavarian pretzels. Non-Euclidean geometry became general relativity's backbone, predicting Mercury's perihelion shift and your GPS directions to the nearest taco truck. Did humans invent a warped geometry and then discover space-time behaves that way? Or did space-time always possess curvature and mathematics simply stumbled onto a pre-existing blueprint the moment they dared to scribble weird triangles on saddle-shaped surfaces? Choose your fighter.
Philosophers sprinted to keep up. Platonists argued numbers reside in a timeless, mind-independent heaven, an ontological IKEA full of already assembled sofas of logic. Formalists like Hilbert countered that mathematics is just a game of symbol manipulation. Axioms are rules, proofs are legal moves, theorems are long-winded checkmates. Intuitionists, led by Brouwer, declared both camps missing the point. Mathematical objects are mental constructions that come alive only through constructive proof. Into this circus strode Kurt Gödel with a pair of theorems that detonated everyone's certainty. Within any sufficiently expressive axiomatic system, there exist true statements you can never prove from the rules inside that system. It's as if chess produces positions you know are winnable, but no finite sequence of legal moves shows how. Discovery? Invention? Gödel simply shrugged and wrote in German. While academia pondered incompleteness, engineers quietly treated math like duct tape. In 1940, George Steinitz used complex numbers to perform the first remote computer calculation over telephone wires. 80 years later, we live stream cat videos across continents using error-correcting codes derived from algebraic geometry. Nobody at the fiber optic factory says, "Hang on, are these polynomials metaphysically real?" They just measure bit error rates and clock out. Let's peek back further, farther than Pythagoras, into caves where Paleolithic humans scratched notches on bones aligned to lunar phases. Were these markings the earliest discovered pattern or the first invented calendar? Anthropologists debate whether those tally marks embody abstract counting or mere decorative scratchwork. Either way, those Pleistocene accountants progressed from tally to trade to trigonometry in only 30,000 short years. That's quick, evolutionarily speaking, the same span that takes a glacier to meander politely across a valley. So maybe there's something inevitable about mathematics blooming in intelligent minds, whether it's discovered or fictively constructed. And the debate isn't limited to ivory towers. Look at your smartphone's autocorrect, which employs probabilistic models to guess whether you type duck or something less feathery. The hidden matrix multiplication humming beneath its glass surface follows linear algebraic rules independent of language. Yet the specific weights in its neural network were invented by gradient descent algorithms chewing through billions of text examples. Are those statistical patterns discoveries of linguistic regularities? Or inventions baked into silicon when a software team decided frustration with tiny keyboards was a monetizable pain point? The arts joined the fray. J.S. Bach wove fugues so mathematically structured that computer scientists use them to explain recursion. Contemporary choreographers embed Fibonacci sequences into dance steps. Visual artists like Yayoi Kusama paint dot fields reminiscent of infinite series. When audiences gasp at the fractal design of Nam Gabo sculptures, are they instinctively sensing universal order? Or did artists simply invent rule sets that mimic nature's aesthetic sweet spots? Even sports sneak in. A quarterback arcs a perfect spiral described by parabolic motion, classic Newtonian mechanics. Yet the spiral's stability hinges on gyroscopic physics that wasn't formally modeled until centuries after pigskin started flying. Did early athletes discover optimal launch angles empirically, or invent them through pragmatic trial and error? Science later reverse-engineered what practice had already found. Now cue the digital fireworks. Artificial intelligence programs like AlphaFold predict protein structures using deep learning and graph theory. The models treat amino acid chains like constraint satisfaction puzzles, revealing folding patterns nature has employed for billions of years. Discovery fans cheer. The math was always there, encoded in molecular interactions. Invention fans retort. The specific architectures, attention heads, gradient clipping, are human-made contraptions. Molecules don't whisper tensors to one another. Yet your immune system doesn't care who's right. It just enjoys better vaccine designs. Consider also that different cultures sometimes arrive at mathematically analogous systems independently. The ancient Chinese developed a method akin to Gaussian elimination.
Let's sprinkle in entropy for messy flavor. Imagine pouring cream into coffee. The resulting swirl is governed by Navier-Stokes equations so fiendishly tough that $1 million Clay Prize sits unclaimed for proving they always behave nicely. We discovered those equations, right? Yet a barista invents latte art by intentionally steering turbulence with toothpicks. She isn't solving a partial differential equation in her head. She's hacking emergent chaos with an artist's intuition. Mathematics describes the inevitability of eventual uniform brownness, but human creativity detours into beauty before equilibrium. Nature sets constraints, we improvise routines within them. Philosopher Ian Hacking calls math's uncanny fit with reality a user phenomenon. We shape tools until they work, then retrospectively declare them discoveries because that flatters the intellectual ego. It's like sculpting a key and, after it finally opens the lock, insisting the key existed in potential all along. Maybe mathematics is part key, part lock, co-evolving with our questions. Yet doubts linger like an unsent tweet. If an alien civilization appears tomorrow, whistling a tune based on 17-toned equal temperament and brandishing a calculus built on golden ratio fractions, would we recognize their pi or argue its heresy? Are universal constants truly universal, or are they filtered through cognitive constraints shared by carbon-based life capable of building radios? Philosophers call this the anthropic principle. Practical engineers call it a reason to diversify conference catering. Remember Max Tegmark's mathematical universe hypothesis? The audacious claim that reality is a mathematical structure. In his view, invent, discover becomes moot. We're fish debating whether water is natural. But not everyone buys tickets to that show. Some scientists suspect mathematics is a projection of physical patterns onto our neural substrates. It flourishes because our survival favored pattern-recognizing brains. If octopuses ruled academia, would we still get prime numbers? Or a moist, squishy analog we can't even fathom? Circling back to our toaster, imagine it now sports a firmware update that lets it compute prime gaps while browning bread. Suppose it finds a counterexample to the Riemann hypothesis between slices. Did the toaster discover a cosmic truth humanity missed? Or did we invent a device that happens to spit out a pattern we call proof? Lawyers will draft patents either way, and breakfast might finally be Nobel-worthy. It's tempting to declare a draw, but the implications ripple outward. Education policy changes depending on stance. If math is discovered, curricula should emphasize exploration and wonder. Students are cartographers mapping a pre-existing terrain. If invented, teaching should stress creativity and design. Students are architects crafting versatile structures. Research funding decisions, ethics of AI autonomy, public understanding of science all pivot subtly on this ontological coin toss.
Philosophical echoes reach into law and economics. Game theory models like Nash equilibria assume players maximize payoff along strictly defined utility functions, useful for predicting auctions, arms races, even Saturday night pizza orders. But if those rational models are inventions contingent on Western economic thought, imposing them wholesale on diverse cultures could misguide policy. Conversely, if they capture universal strategic realities, ignoring them invites disaster. Just ask anyone who's bid on eBay at 2 a.m. and lost to a last-second sniper bot executing pure Nash math. Is the model discovered truth or neo-colonial arithmetic? Consider everyday algorithms that recommend videos or set insurance premiums. Behind each sits a tangled mesh of probability theory, linear algebra, and optimization. The math seems neutral, yet outcomes may entrench bias, spotlighting how invented parameters influence discovered correlations. The invented-discovered tension becomes an ethical live wire. Who bears responsibility for patterns we claim are just math? And then there's play. Mathematicians delight in recreational puzzles, Penrose tilings, Conway's game of life, origami theorems that let spacecraft fold like gift wrap. These delights feel simultaneously whimsical and inexorable, as if we conjured playgrounds only to find immutable laws already policing the swings. The mix is what makes mathematics gorgeous. Part serendipity, part craftsmanship, part cosmic Easter egg hunt. By now, you've finished several sips of coffee, and perhaps your toaster has relented, charmed by the sheer exuberance of our detour. But the question, like an unsolved integral, persists. When the next breakthrough emerges, whether a quantum gravity equation scribbled on a physicist's shower wall or a combinatorial identity discovered by a bored teenager on TikTok, will we say, "Ah, a new continent on the map," or "Ah, a new castle built with familiar blocks"? The universe may never adjudicate. And that is exactly why the debate thrives. It keeps classrooms buzzing, conferences caffeinated, and late-night dorm chatter gloriously alive. Maybe the deepest joy of mathematics isn't settling the score, but relishing the process, toggling between marveling at the universe's elegant structures and applauding our own ingenuity in naming, proving, exploiting, and sometimes misplacing them. So let's leave the last word to you. When you gaze at a spiraling galaxy photograph or debug a stubborn Excel formula, do you feel like an archaeologist brushing dust from eternal truths? Or a composer inventing melodies the cosmos might hum along to only once you've played the first note? Whichever tale you tell yourself, the numbers will keep whispering possibilities. The real discovery or invention may be the conversation itself. If this exuberant ramble sparked a grin, an epiphany, or a desire to yell at your toaster, smash that like button. Share the link with someone who still thinks imaginary numbers wear capes, and unspool your boldest take in the comments below. After all, the argument, much like Tao, pi, goes on.